Hello, this is going to be the first of two videos on the rules for assigning oxidation numbers. In this first video, we're going to look at the rules. In the second one, we will apply those rules in a number of examples. So oxidation numbers are used for bookkeeping purposes. They allow chemists to balance redox reactions, oxidation-reduction reactions. They allow us to determine if a reaction is an oxidation-reduction reaction. Oxidation numbers can be positive or negative. They can be integers, or they can even be fractions. Don't confuse oxidation numbers with charges. When we're talking about covalent molecules, there's no such thing as a charge on any of the atoms. These oxidation numbers are fictitious that we assign to the atoms. They're just helping us see what electron transfer might be taking place. So here are the rules. Rule number one. The oxidation number of an element is free or uncombined state is 0. For example, if you just have plain old metallic aluminum as a solid or zinc as a solid, each of their oxidation numbers of those atoms is 0. If we're looking at a diatomic species, such as molecular hydrogen or oxygen or nitrogen or any of the halogens, fluorine, chlorine, bromine, and iodine, they all come as two atom species, in which case each of those atoms all have an oxidation number of 0. It's also true for phosphorus, which can be found in nature as either P4 or P5. The oxidation number on any of those atoms in phosphorus is 0. And sulfur, as a molecular species, comes as S8. It has an oxidation number of 0. Rule number 2. The oxidation number of a monatomic or one-atom ion is the same as the charge on the ion. So sodium ion is a +1 charge. Its oxidation number is +1. Sulfur, when it becomes an ion, becomes the sulfide ion. It has a -2 charge, so its oxidation number is -2. Rule number 3. The sum of all the oxidation numbers in a neutral compound is 0. So let's look at water. It's a molecular species. There are no charges, but we can assign oxidation numbers to each of the atoms in water. So hydrogen, we have 2 of them. They're both +1. The oxygen is a -2. We add up those oxidation numbers, and they sum to 0. The sum of the oxidation numbers in a neutral compound is 0. Now, how that hydrogen got a +1, that oxygen got a -2, we'll look at in a subsequent rule. Rule number 4. The sum of all the oxidation numbers in a polyatomic or many-atom ion is equal to the charge on that ion. So let's look at the sulfate polyatomic ion, SO4 2-. Sulfur has a +6 oxidation number, and each oxygen, we've got 4 of them, has a -2 oxidation number. 4 times -2 is -8, +6. If we sum up all the oxidation numbers, that equals -2. That equals the charge. The sum of all the oxidation numbers in a polyatomic multi-atom ion equals the charge. Rule number 5. The oxidation number of an alkali metal atom in a compound, such as lithium, sodium, potassium, is +1. Likewise, the oxidation number of an alkaline earth metal group 2A in a compound, such as beryllium, magnesium, calcium, is +2. Those are the only charges those metals ever get. So when they're charged species or ions, they're going to have those particular oxidation numbers. Rule number 6. The oxidation number of fluorine is always -1. So when you see fluorine in a compound, it has an oxidation number -1. I'm not talking about F2. In F2, that oxidation number on each fluorine is 0. But when you put fluorine in a compound, its oxidation number is always going to be -1. Chlorine, bromine, and iodine usually have an oxidation number of -1, unless they're in combination with an oxygen or a fluorine. Rule number 7. The oxidation number of oxygen in a compound is usually -2. There are some exceptions. A few compounds are known as peroxides or superoxides. And we'll see some examples of that in the next video. Rule number 8, the oxidation state or oxidation number of hydrogen in a compound is +1, if it's combined with a nonmetal, which is the usual case, or it's -1 if it's combined with a metal. And so up above, when we looked at H2O, hydrogen is combined with oxygen. Both of them are nonmetals. There, hydrogen has a +1 charge. Whereas if we make a hydride, like sodium hydride, that sodium ion is always a +1 charge. That hydride ion here, that hydrogen actually has a negative charge, and it'll have a -1 oxidation number. So that's the end of part 1 of rules for assigning oxidation numbers. In the next video, we'll look at some examples.